Example B says we need to find the distance between the point 1,5 and the point 5,2. So if we were to look at that on an xy graph, we're looking at the point 1,5 right here and the point 5,2 right here. So what we're really looking for is this diagonal distance from here to here. Well, one way to do that would be to take a look using the Pythagorean Theorem as our reference here, and to see that what we're doing is going from 5 vertically down to 2 vertically. So we're going 3 units this way, and then we're going from 1 horizontally over to 1, 2, 3, 4, 5 horizontally. So we're going across 4 this way. So what we have is a triangle that has sides of 3 and 4, and what we're looking for is the other side. Well, of course, 3 squared plus 4 squared equals c squared would be our triangle then. So we have 9 plus 16 equals c squared, and 9 plus 16, of course, is 25. If 25 is c squared, then c is 5. So that would tell us that this other side of this triangle would be 5, and that would tell us that the missing side was 5 units long. Now the other way to look at that same information is without using the actual xy graph there. We can use the distance formula, which is really a derivative of that Pythagorean theorem, and looks like this. If we have A be 0.15 and B be 0.52, and we plug that into the distance formula, then we take 1 minus 5 and we square it, and we add that to 5 minus 2 squared, which gives us 1 minus 5 is negative 4, and 5 minus 2 is 3. 4 squared is 16, which you probably remember from my other example over here. And 3 squared is 9. 16 and 9 is 25. Square root of 25 is 5. So of course we get the same answer because it's really the same process. It's just using it with or without the picture. And the goal for example C is to see whether the triangle ABC is right, obtuse, or acute. And all we need to do there is find out what the lengths of AB, BC, and AC are, and then run those lengths through the Pythagorean theorem. If we call this side B over here, and this side A up here, and this side C down here, if A squared plus B squared is greater than C squared, then this would be an acute triangle. If A squared plus B squared is less than C squared, then it's an obtuse triangle. And if they're the same, then it's a right triangle. So we just need to figure out what those lengths are. So if we run the length for AB, which we're calling side B in our triangle right here, then we have, with our distance formula, we have negative 4 minus 3 squared plus 1 minus 8 squared equals the square root of 49 plus 49, or the square root of 98. Then side A over here would be the square root of 3 minus 9 squared plus 8 minus 6 squared, which gives us the square root of 36 plus 4, or the square root of 40. And then finally AC, which we're calling side C down here, is the square root of negative 4 minus 9 squared plus 1 minus 6 squared, which would be the square root of 169 plus 25, or the square root of 194. So then what we're doing is finding out whether this squared plus this squared is equal to, greater than, or less than this squared. So we have the square root of 98 squared plus the square root of 40 squared and the square root of 194 squared. And the question is, how do those relate? Well, the square root of all of these squared is just going to cancel out. So is 98 plus 40 greater than, less than, or equal to 194? Well, 98 plus 40 is 138. So obviously it's going to be less than 194. So this triangle right here is obtuse. And that's all we have.